flammability limit depends on temperature and pressure. So generally the flammability range increase with temperature. Okay, this is the correlation between the LFL, okay, the previous LFL which is based on 25 degrees Celsius, now with the temperature dependent. Okay, so you have LFLT equal to previous LFL minus this term. Okay, this is the correlation. This is the term that will correlate the previous LFL with 25 degrees Celsius temperature to the new temperature dependence. Okay, so you have delta H is the heat of combustion, while T is the required temperature. So you have LFLT and also UFLT. However, both of these equations, just to approximate, okay, just try to estimate and only valid for a very limited number of hydrocarbon over a limited temperature range. Okay, so the pressure has little effect on LFL except at very low pressure. However, UFL will increase significantly as the pressure is increased. So your LFL and UFL will be correlated to the temperature and also UFL with the pressure. So your new UFL is based on pressure is equal to UFL plus 20.6 log pressure plus 1. Okay, so your pressure make sure in megapascal, and UFL, okay, your previous UFL is the upper flammable limit based on 1 atmospheric pressure. Okay, we will look one of the example how we can utilize this equation. Okay, example, if the UFL for a substance is 11% by volume at 0 megapascal gauge, what is the UFL at 6.2 megapascal gauge? Okay, we try to find what is the absolute pressure at this situation. Okay, it's 6.2 plus 0.101. Okay, this is atmospheric pressure, but in megapascal. So you have your absolute pressure is 6.301. Okay, then based on this equation, okay, you already have your P, okay, log P in absolute pressure. So this is your old UFL, okay, if the UFL for a substance is 11%, okay, by volume. So 11 plus 20.6 log 6.3 plus 1. Then you got your new UFL based on your new pressure, which is 48 volume percent fuel in air. Okay, that's how you can relate your UFL with the pressure. Okay. Okay, we look what we try to determine what is the flammability limits. Okay, without experimental data. Okay, so for many hydrocarbon vapors, the LFL and UFL are function of stoichiometric concentration. Okay, so your LFL is 0.55 stoichiometric concentration, and UFL is 3.5 stoichiometric concentration. Okay. Then what is your stoichiometric concentration? So your stoichiometric concentration is equal to moles of fuel over summation of moles in fuel and air. Okay. The stoichiometric concentration for most organic compound is determined using general combustion reaction. Okay, we will utilize this combustion reaction. Okay, so you have your stoichiometric Z equal to M plus X over 4 minus Y over 2. Okay, so you got your Z is the moles of oxygen over mole of fuel. Okay. So you have your stoichiometric concentration. Alright. Finally, you can summarize your stoichiometric concentration as equal to 100 over 1 plus Z over 0.21. So Z is your moles of oxygen divided by moles of fuel. Okay, so substitute Z. Okay, you try to determine what is your Z, and then you can apply the equation of LFL and UFL. Okay, this is the final equation for LFL and UFL. Okay, how you can determine based on stoichiometric concentration. Okay, based on your stoichiometric concentration. You also can determine. We also can determine the LFL and UFL using another correlation method, where we have the flammability limit as a function of heat of combustion. Okay, instead of using stoichiometric coefficient, we try to determine the LFL and UFL according to heat of combustion. Okay, so this method should be used only for quick initial estimation. Okay, so this is an example how we can calculate the LFL and UFL for hexane, and then we try to compare what's the difference between the calculated limits to the actual values that have been determined experimentally. Okay, so hexane, through the combustion equation, we try to balance the equation and get the value of M equal to 6, X equal to 14, and Y equal to 0. Put back into the equation of LFL and UFL. Okay, you have your LFL is equal to 1.19% volume percent, while UFL is 7.57 volume percent. Okay, let's compare with experimental LFL and UFL. So for experimental LFL is 1.2, while UFL is 7.5. So there's not much different for this case. Okay, for this case only. Okay, it's either using the experimental or the estimation equation.